Not too loud? Or not too quiet? I changed a few things right before I started. The styrofoam really didn't work that well. Decided to go for a cutting board instead. Alrighty then. There's plenty of questions and plenty of chat that I need to address. I'll just go get through it and then we'll begin. But before we do that, actually, the music was nice, wasn't it? I wanna continue playing it. But I need to set it up because I forgot. I was rushing too much. There we go. Just let me know if the music is too loud or too quiet. Nice cleaning technique with your tank top. Oh yeah, you use what you can. The garden behind is beautiful. Yeah, it's really nice. I do like the garden. It's just I can't catch a nice view of it with the camera, but it is a beautiful garden. What do you do for a living? I am an architect and a teacher of architecture. That's what also a YouTuber, I guess, at this point. I don't know how many subscribers you need to have to actually be called a YouTuber, but I guess I'm one of those. One of those YouTubers. I assume that's hello from Malaysia. Hi Thomas. Hello. Can't hear. I assume that's can't hear, but that's an old message. I only started speaking just recently. Yeah, I think he's an architect and a teacher of architecture. That is correct. I'm considering to join your membership. What's the difference between joining Patreon and YouTube? The Patreon members get the Grasshopper definitions. YouTube members don't, unless you email me and you say that I'm a YouTube member, then I will send you the definition over email or something like that. It's more convenient to be a member on Patreon if you need the definitions, the Grasshopper scripts. If you don't, then it's whatever. And hi from Colombia. Hello. Welcome. Hi from China. Hello. Welcome. Alright, so now we can begin. So the thing that I have, well, not planned, but what I want to do today is actually going to be twofold. On one hand, we're going to do some Arduino stuff, and I have some stuff prepared and even a little bit of a USB cable dangling here that we're gonna use. And also, I'm not sure if the camera is gonna pick it up, but we have this. Does the camera pick it up? Not doing great. Maybe like that. Yeah, that's a bit better. Wait, in the shadow. There we go. Remember this sub-D house? I'm gonna start making a model out of it, as I have all of the elements drawn out, like separate pieces drawn out for like half of the model, and then we're just gonna see, you know, what's the, if it's gonna work or not, basically. What's the procedure to make it work? So that's going to be second half of the stream, or maybe I'm gonna mix and match them. But for now, I'm going to work on Arduino. Arduino Nano, I guess. So for those of you who were following the YouTube videos, that physical model that I was just talking about, that's going to have a little bit of a motor system and sensory system. So basically it's going to open up and close up whether something happens, some sort of sensor gets triggered. So what I want to do today is just kind of troubleshoot and build that system and see if we can get the sensor to be recognized, if we can get the motors to spin. I'm not sure if we can though, because the motors that we're gonna be using are these bad boys. Here we go. Stepper motor and the driver board, and these bad boys eat up between 5 and 12 volts, and this board can dish out basically 5 volts, not more than 5. If it's more than 5, it's gonna burn. So this basically this is the maximum voltage, and this maximum voltage of this one is the minimum voltage of this one. Wanna see some fireworks, kids? we're gonna try and make this spin, right? So that's one part that we're gonna try and do. The second part is gonna be, or I guess the first part is going to be the sensors, right? And actually hooking up a sensor to it. And I forgot to bring the sensors. I'll be right back, but we're also gonna use this, the breadboard. So just, you know, a few fun little experiments before we will jump into actual model making with balsa wood. I will show you how much wood I bought for this model. I think that's a little bit of an overkill. Oliver says hi from London and that I'm awesome. Not sure about the second statement, but hi Oliver. Hi. And Chimney says hello from India. Hello, welcome. Hope you're gonna enjoy this completely non-Rhino, no 3D modeling stream where I'm just gonna chill. It's gonna be a little bit different, I guess. Give me half a minute, maybe less, 20 seconds. Okay, we're back. We're back. 37 sensor kit. I need to get used to this new camera setup. 32 sensor kit. We're gonna just use one of those, and we're just gonna try out basically only one of those to see what works. And I'm thinking, oh, did I forget to, oh crap, I forgot which one is which, and oh, there is a bit of a guide for it. We can use a knob. Yeah, there we go, a Rotary Encoder. I want that. I want a Rotary Encoder. That one looks like... Oh cool, we have a laser. There's a... Come in. Come on, focus. Focus. We have a laser. Or just a diode. Anyway. Rotary Encoder, huh? No, you're a speaker. The hell are you? You are a Rotary Encoder. Okay. So we're gonna be using that. And as we turn it, it's going to probably drive our Arduino. Hopefully. Sorry, not Arduino, our motors. Not our Arduino. So now you go back here, you go back here, you go in here, bam, bam. That one goes in here, bam. That's selected. Right. The motors will come in a little bit later. We don't need those. For now, we are going to be just using these three. So I'll start by plugging in my Arduino board to my computer. There we go. That's done. And actually, now we will need to see what I see on the screen. So I will be doing a few changes here. Canon phone needs to be smaller. Whoa. Just okay, there we go. Something like that. Yeah, I think something like that will work. And then webcam, we can increase the size of this one a bit, because that's whatever. There we go. Okay. And now here, we just need Arduino. Just wait for it to load up. Is that good? That seems to be okay, right? Yeah, that seems to be okay. So what do we have here? Analog. Blah, blah, blah. Oh, that's the moisture sensor. Nah, that's an old news. We don't use that anymore. We are going to create a new file. Was the old one. Perfect. And then I'm just going to make sure that this little bad boy here is recognized by our machine, by our laptop. So I'm just going to go to Tools, wherever it says Board Arduino Nano. That works, yeah. Processor 80 mega old bootloader. Yeah, that's perfect. Port COM3. Yep. That's the only port actually that we have. Get board info. Oh my god. That's what you get with a 4K screen, I guess. Unknown board. Yeah, that's fair enough. This is a that's a Chinese copy of a original Arduino. Is that chai? No, that's just regular coffee with milk. I'm not well, I do drink tea, but I'm much more of a coffee person. Enjoy it much more. Okay, so now we need to figure out how do we read from the Rotary Encoder, and also how do we hook it up, because it has like 4 inputs here. Will you zoom in? Or sorry, it has 4. Oh my god. It has 4 outputs, right? Ground, voltage. Sorry, it has 5 outputs. Ground, voltage, and 3 that I have no idea. Well, one of them is going to be signal for sure, but other 2 I have no idea what they mean. So we need to Google a little bit. Let's see. Rotary Encoder Arduino. Yep, that's the one. That's the one. So there are like two outputs. Okay, we need this one. This is how we're gonna hook it up, right? I think. No, wait, that's only 3 wires. That's the wrong one. That's the 5-wire one, but I actually want to see a decent... like a decent schematic. Maybe that's a good enough one, right? Ground to ground, 5 volts to voltage, but that's 4. The middle one is missing. SW. SW is missing. What does SW stand for? And do any of other ones have SW? SW is also not hooked up here. Okay, so we just ignore it, I guess. We just ignore it. Right. So now, wires. From male to female, back to male. Yep. So from male to female is that. I'm just using a breadboard because I know for a fact that I'll need more than one 5-volt output. I'm just gonna have in between. I'm gonna have the breadboard. Okay, so ground is here. Ooh, that's a shitty fit, but seems to be fine. Then we will need like 1, 2, 3 more. So I'm just gonna do it this way. That. Separate one of them. That's gonna be voltage. That will also need to be broken out. So ground and voltage both get a special place in this breadboard like that. Perfect. And then we have 2 more wires. Blue and purple. I should probably get wires that have different colors, but you know, whatever. There we go. Okay, so now for those wires. No, not this one. This one. Trying to somehow show it to you guys as well. Oh, come on. What a wonderful... Okay, so these two are easy, like 5 volts and whatever, the ground is easy, but the other two are... Oh, those are just digital outputs, digital pins. We have a shit ton of those. But wait, are those analog or digital? Those should be analog, right? No, those should be digital. Yeah. Okay, let's do 4 and 5. So wait, so these actually shouldn't be male-female. These should be female-female connections. Oh, that's good. That's gonna have different colors. Just do that. Oh my god, this is annoying. How's your summer, guys? Having fun? waiting for the school year to start? For those of you who are still students? I'm gonna go for D3 and D4. Like that and like that. So the gray one is D3 and the purple one is D4, which means CLK is D4. I need to write this down. I'm just gonna write it here somewhere. CLK equals D4. The other one is DT. Equals D3. Just so that I don't forget and that I don't need to check it that often. Okay, now the interesting bit is us hooking up the ground, which is this pin right here. Come on, there we go. This is way too small. And then hooking up 5 volts, which is this pin right here. There we go. And ground was gray. Okay, so this goes here. And 5 volts goes here. So for those of you who have no idea what the hell is going on, this is basically going to enable me to have multiple... It branches out the wires. Let's say it like that. Like this board branches out the wires. So I'm trying to show you here. These two wires, these two, are inputs, which means that all of the other holes in those rows are going to be outputs, right? So 5 volts and ground, since those are inputted here, they're going to be outputs on all other holes that are aligned. But this one should be now kinda hooked up properly. We'll see if it's gonna work or not. I need an example code to actually see if this is gonna work. Rotary Encoder Arduino example. Oh, that's a big boy code right there. Okay. Anyone has experience with rotary encoders? Output, sensory technology, incremental absolute. Yeah, okay. This just explains the encoders themselves. Ain't nobody got time for that. We instead will look at... Do you have an example file? Let's Ella go. Okay. Last minute engineers, how to... Okay. Yep, that's the one. DT and pins must be connected to the interrupt foot of Arduino Uno or both of the... Wait, Uno? I don't have an Uno. Does this mean that... No, this should still work. Or maybe not. What the hell is SW, the yellow one, whatever. Pin 2, pin 3, pin 4. Okay, that's all fine. And then we have the definition here. Okay, do we just YOLO it? I'm just gonna YOLO it. Come on, just give it to me. All of this, please. Define encoder pin A, pin B. So pin A. Okay, fine. We're gonna do it. We're gonna just straight up copy it. We have D4, D3, D2. Wait. No, that's ground. We just have D4 and D3. That's pin 4, pin 3, pin 2. SW24. Okay, fine. I don't have SW. This is so ghetto. Then DT is 3, yes, and CLK will need to go to 2. Easy. You know what's the rule number 1 of streaming? Never stream something that you don't know how to do. Just saying. Just saying. Like the worst idea possible is to try and stream something that you have no idea how to do. There we go. Okay. So now this should be working just fine. Which means I can upload the... Let's verify first. Let's save first and then verify. I'm just gonna upload and check if... Oh, that's because of my notes. No, that's not because of my notes. Okay, so if values are not this one is here. If no, that bracket needs to close or not. Wait. Okay. That seems to be... We have fixed it. Oh, do you know what CV means? CW and CCV. That means clockwise and counterclockwise. Oh my god. Okay. So we have our sensor working. So the way this works, can you see it by the way? Yeah, you can. Can I make it bigger? Hello? Make it bigger? No? No, I can't. Okay, fine. But basically the way this works is those values that we're currently getting is the position of this knob right here that you see. And we can kind of 3D print like a nice knob here, and it's going to understand. So I think we can, there we go. So right now I'm back at 0, right? So this is as if the knob is not turned, and then I can take it and I can turn it clockwise by 3 clicks. So I can feel these kind of small clicks as I'm turning this, right? So 1, 2, okay, that doesn't, oh, never mind, there it goes. It's a little bit funky. It seems to be working, right? So I keep increasing it, and I can go pretty far, right? Up until, let's go for 200. Okay, 200. A little bit back, there we go. So that's 200 in counterclockwise direction. And now I can turn it back to 0, right? So if we hook it up to a motor, that means as we're turning a knob, the motor can turn together with the knob either clockwise or counterclockwise. Might be something pretty cool. Let's see. Let's burn the whole place down to the ground. Where's my stepper motors? So remember when I said that stepper motors uses 5 volts at minimum and 12 volts at maximum, and this board can only dish out 5 volts? Let's see what happens when we try and hook it up directly to the board without any safety measures whatsoever. This is gonna be so stupid. So stupid. Oh, they even give us like small DuPont cables. That's nice of them. All right. So this is what's called a driver board, and it drives the motor, right? And we just simply hook up the motor to the driver board like that. Perfect. And now unspin it. That's good. And now we need to figure out how the hell do we hook it up. So we need two wires, one for ground and one for voltage, and I think this is where it's gonna burn. Right. So we hook up. The black wire is going to be for the ground, and the white wire is going to be for the voltage, and it doesn't want to be hooked up. Can't blame it. There we go. And the ground was, what was the ground? Black, right? Yeah, black was the ground one. So it gets up here, and the white one gets hooked up here. Okay, seems to be still no smoke. Seems to be still working. That's good. So now, since we passed this test, maybe we can actually drive it with the freaking Arduino board. We'll see. My thoughts are that no way. Oh, here. We need documentation of it though. Stop that. Okay. Where's our ULN 2003 Arduino? Let's see how we need to hook it up. Yeah, so see where it has the batteries? We're not using that. We're saying YOLO. We're just going to straight up go for... We're just going for this schematic. By the way, I somehow feel like I should tell you this. Please don't do this at home. Please don't. I mean, don't. Or if you do, have be ready to extinguish a small electrical fire. These are not high voltages, so it's not that bad, but still, you know, not the smartest. Alright, we need wires, and we need female wires, and we need 4 of them. There we go. The 4 of them will go here. 1. A perfect fit. And then they will need to go through D5 until D8. Okay. This is gonna be bad. Once we burn this, we'll start doing the Balsa model. I think, yeah. Okay. Have this hooked up. Nothing's glowing. It's not on. That's fine. It's fine. So now, since we have this going on, we need an example file. Okay. First, we take a look at this stepper library. Oh, that's boring. That's boring. I want the cool stuff. The example file. Okay, so we need stepper.h library, which we can probably just straight up install from the library manager. One of the best Rhino tutors? Well, definitely not the best Arduino tutor. At least that. What else was I looking? Oh, stepper. No, stepper. There we go. Stepper. Oh, it's already installed. Okay. I'm just gonna install that one as well. Why not? Anyhow. Oh, it's already installed also. Okay. So we need more. We need this little board to do more stuff. First of all, we include the library. Or maybe we just do, let's do, we will Frankenstein them together, but for now, let's just straight up copy this whole damn thing, this whole example file, and let's just paste it here. Include stepper.h, steps per revolution, whatever, pin 8 to for the... No, I'm not using those pins. No, I want different pins. I can't change the pins? Ah, there we go. I can. Okay, so from white we have 5, so that's 5. and then the gray one goes into 6, then the blue one, oh, the purple one goes into 7. Oh yeah, 5, 6, 7, 8. Easy. 5, 6, 7, 8. So that's the speed. That's the communications begin. Print line clockwise. Steps per revolution. It's gonna make 2048 steps. Then it's gonna wait, and then it's gonna go back. Okay. Time to burn. We need to open up them. This guy right here. Upload. Ah, yeah. Sure. Save. Okay, so now. Oh. Why does it keep deleting stuff that. No. Upload. Please don't burn. We're looking at this, and we're looking if this is gonna spin. It's actually spinning. It works. You can't really. Can you see it? Wait. Yeah, you can kind of see it, right? This little doohickey here spinning. Oh my god. We are spinning it without using any additional power, just through the board. And the board just slightly smells of electronic fire. This is so stupid. But, hey, it works. Vibrates like crazy as well. Okay. We have it going. So that's all I wanted to do with Arduino today. Let's just unplug it for a second. Or no, let's unplug it from here. Bam. Okay. So that's all I wanted to do with Arduino for today. Pretty fun. We have an encoder that's the rotary encoder that's working, and we have the motor that's spinning, and we have 2 codes rather than 1, but I think that is absolutely fine. We will be joining those up into 1 code eventually, right? As we spin the encoder, the motor spins. So that's gonna be fun. I think we can now move on to actually doing some Balsa stuff, right? Model making stuff. That's gonna be pretty neat. So let's enlarge this back to normal. Let's make me smaller. Let's take the whole damn Arduino thing, or Frankenstein. I'm gonna move it away, and I'm gonna bring us some balsa wood. 10 seconds? 15 seconds? Okay. We have ourselves a little bit of a box, and actually, I think we can kind of do a little bit of an unboxing of a thing here. There we go. Yeah, that seems fine for a bit. Just found out about your channel. Greetings from Brazil. Welcome. Welcome to the channel where most of the time I have no idea what the hell I'm doing. All done. Also, this is the stuff that we're going to be using for our model, our physical model. Come on. Just need to check if there are no important documents inside. Don't want to show those. Seems okay. Seems good. Little bit shitty packaging, but there we go. And the box goes for now there. Okay. So what do we have here? The good stuff. The good stuff. This is... I have no idea what this is. I don't remember what I actually ordered. What the hell? Oh, right. So this is going to be used later. This is like lac that we're going to use for the Chinese paper. That's gonna be much later. For now, care about the balsa wood. Damn, this is so unecological. The packaging is horrible. Okay. Is there? So those of you who are in the construction industry already know this, but wood has become really expensive in the last, I don't know, how long? 3-4 months? For this amount of balsa wood, I paid, I'll say it in dollars, it's like $75 just for, just for this. This is horrible, honestly. Like the price is just horrible. Wish we came back to the good old times. This is the stuff that I have, and basically we're dealing with pretty thick boards. That's gonna come in handy later. I believe these are 3mm boards. I will need to check, but these seem like they are 3mm thickness boards. And then we have super thin ones. This is 1.2mm. And we have quite a few of them, actually. Right? So these are like separate, like legit separate pieces of wood that we'll be using. And that's basically it. I think I ordered more, but maybe I haven't. So that's doesn't smell like anything, but that's what we're going to be using. I am going to start with okay. You will be. I'm probably going to start by measuring the thickness and getting the correct one, right? The correct sheet. The camera needs to focus up on the table again. Good enough. How's the brightness? That's actually fine, right? Yeah, that seems to be fine. Okay, so we're gonna use that. I'm gonna use my trusty how are these things called? Calipers? I think those are called calipers, right? Wait, color is weird. There we go. Old. Or maybe let's go for warm, right? Yeah, I think that's fine. I'm gonna use those. Let me tell you about today's spot. No one's sponsoring this channel. We have. Wait, that's 4 mil. Wait, oh no. Reset. What the hell? Why is this number so weird? 3.85. Okay, what about here? 3.8. What about on the other side? Like here it says 4 millimeters. So I wanna call bullshit. 3.6. They are scamming me. They are scamming me. We'll need to remodel a little bit if all of these pieces are crap. Yeah. Let's see this one. 1.6 and it's written. Nothing's written here. No idea. But 1.6, that's a little bit more reasonable, but we do need to open up ourselves the 3D model and just check it out. Let's use that one. Oh, you can't see it. Wait. Wow. Why does this not keep the proportion? That's weird. That's super weird. Yeah. New version of V-Ray. Okay, so this is the one that we're going to be doing. Like this is the model, the portion of the model that we're going to be starting with. Of course, we're gonna start very simple, right? But I care about what's the thickness here, right? What's the thickness here? Perpendicular. Oh, come on, just snap, please. Hello? So stupid. Isolate then. Distance from here to here. 2 millimeters. Uh-oh. And that one was 1.6, right? Now the question is, amongst all of these... Ah, nope. You stay. You become bigger. Amongst all of these, do we have any that are like at least close to being 2 millimeters? It seems to be pretty close. A pretty thick boy. Where's my calipers? .2. No, I swear to God, like the error threshold for these pieces of wood is like, I've ordered 2 millimeter pieces. Some of them are 2.2 or 2.4 millimeters. The other ones are 1.6. Pisses me off. Okay. That's fine. We'll make do with the thicker boy here. So now, let's actually do some. Let's do some work. So you don't really need to see the model, I don't think, or do you? Well, when I'll be doing something with the model, I will be showing it. But for now, I'm not gonna show it because it's just empty. So you're not gonna see it, and we are going to fish out the correct page. Nope. Yep, that is the correct page. These guys go here. We're gonna do those later. We have this. Any ideas? I don't need a keyboard. Need more space here. The mouse could go here as well. Go away, mouse. Okay. Any idea on how we can transfer the drawings from here onto Balsa? Any suggestions in the chat? I'll give you like 10 seconds or 20 seconds to come up with ideas. If you don't, then I'm gonna do it my way. Tracing paper? Sure. I don't have it. Acetone? That's gonna mess up the wood. Like balsa wood is... You can think of balsa wood as sponge. So the acetone is just going to... Like the ink is going to bleed like crazy, and it's going to mess up. Yes, it is a scalpel, but we are going to use it, but we're going to use it later for the actual cutting of things. I'll show you one little trick before we end the stream. how to make yourselves a pretty cool tool for cutting thin pieces of wood. That's gonna be at the end of this stream. Punch many dots. That is the plan. So Thomas is correct. We are going to punch a bunch of dots with these sticks right there. If you were using anything else than balsa wood, acetone would work just fine. Or tracing paper. Well, actually, tracing paper is maybe even better than punching a bunch of dots. But since we are using acetone, since we are using balsa wood, punching a bunch of dots is the only real solution. Before I do that, I will be cutting away pieces just so that it's easier to handle. One. Like, what was it? Glue and cut paper on wood? Yeah, I could do that as well. But I would need the, whatchamacallit, the stick glue. I don't have that. I don't want to use wood glue with this technique. But yeah, that's another good way of how to do it. You just glue the pieces of paper onto wood and cut them out. Sure, that works. What was it? Around 10 years ago, more than 10 years ago, as I was studying or attending aviation modeling, like a group, we would be using this kind of a pin technique on our airplane shells, like as we were making the airplane shells. But the difference was that you needed to also kind of, how do I explain this? The balsa wood that we used was super thin then, like for the airplanes. So acetone and other, like, you couldn't glue, for instance, the piece of paper to the shell, to the balsa wood shell, just because it was as thin as the piece of paper, right? So you could break it easily. So small pins were the only solution. With something like this, you know, with an architectural model, there's a crap ton of different ways of how you can do it, for sure. This one will come in handy later, as I will be placing these sections, these cuts, as I'll be placing them so that I could add the cross bracing for them. But this will come in handy later. I can even throw away a few unnecessary bits and pieces here so that it's smaller. Okay, that's that. And here we have like a few, I can make it a bit more compact, but just a few crap pieces left. So back to our balsa wood. I honestly almost wanna cut it, you know, and work with it in smaller pieces, but I'll try not doing that because that's going to mess up my whole flow. Instead, we are going to use these pretty pens, pretty nails, and see if they actually leave a mark. Yeah, perfect. And all you need to do is just go around the perimeter and punch a bunch of holes. Like I'm punching holes you can't see it, I know. Maybe. Yeah, that helps a little bit, right? So I'm basically punching every I shouldn't say it in distance. I'm punching every 2 degrees, 2 or 3 degrees of how much the angle of the curve changes, right? So in tighter turns, I'm punching holes much closer together. I missed that one. Also, it kind of hurts. I ain't gonna lie. Wait, I'm gonna find some. So it's a good idea to leave a few pins in, just so that your paper doesn't fly off. Wait, I'm gonna find something to use on my finger. Okay, sure. We're going for electrical tape. We're going for electrical tape. That's gonna be good enough, I think. I managed to actually open it up. Wow. That's too much. Forgot that it's super, like, if you tug on it, if you tug on the electrical tape, it will give, but it's going to recompress really heavily on your fingers. It's gonna be pretty bad. It does that. Use pins instead of glue and cut it. Don't trust myself with it. I don't think pens will. Well, actually, we will be doing one experiment with that idea. Because I have bought a bit of what's it called the foam board, a little bit of foam board, so we can actually kind of use pins drastically with it. But the first the first instance here, I'm just going to make a bunch of dots on the balsa sheet. And I messed it up. That's the problem, right? That's the problem. Is that everything's kind of, since everything is soft, everything is falling apart a little bit. Just give me a second. This should do the trick. And now we can push through it with the pins. Not sure if this is gonna work or not, but hey, we can try. I'm just thinking, wait. Maybe I'll try with the pins just for a bit. You could also just draw on top of a ball pen or something, since the balls are so soft it will get the markings. Yeah, that's true, but it's the same, it's kind of the same thing, right? As me just making a bunch of holes. Like the speed would be the same. Is the cut visible? Yeah, the cut is visible. I have cut it all the way through. Why the hell? Just explain to me. Why the hell did I decide that I'm not gonna use a laser cutter for this project? Huh? Who came up with that idea? So stupid. So stupid. I guess it's a little bit meditative, right? With this approach. Okay. So we have that going on. Now, let's just do this. That. I just wanna see if me cutting it now will work or not, without actually looking at the points. Nope. It immediately put a tear in the paper. Maybe it's the knife. Let's change up the knives. Let's see. Nope, it's not a knife. It's the paper is shit. It's an office paper. What do you expect? Of course it's shit. So instead, we are going to make a bunch more holes and then remove the paper. And then make a cutout. And the inner ones don't need to be that accurate, because no one's gonna be looking inside. We just need to have like an approximate marking. What kind of videos do you guys want to see next? Me working on next? I got contacted by some Chinese company that is creating these kind of web-based like servers that work with Arduino, right? And you can basically let's say you hook up a temperature sensor to your Arduino board, and then your Arduino board sends that temperature to that web server, and that web server, you can access that information over an app, right? So you can create an app that will work with your Arduino. So the interesting thing for us as designers is that we can use apps to kind of drive our either models or, you know, make smart houses and so on, just with that server service and the cheap Arduino, which is nice because a smart house like solution costs thousands of dollars, right? So if you can have something for much cheaper, why the hell not? So that's one idea, or not an even idea, but one direction where I could take these videos. I'm just curious to hear from you if you have any suggestions. Corners are always a hassle. Use scissors. Scissors will crush the balsa wood quite a bit. Don't want to use scissors for that. But what I want is definitely coffee. Good day, sir. Good day. Hello, welcome. Welcome to a weird stream. Welcome to a very weird stream. Show us your 3D. Show us your 3D printers and how they work. Nightmares she. I don't have any 3D printers here. During summer, I'm not staying at my house, right? So this is not my house. This is just a quick makeshift. I don't even know how to call it. A quick makeshift studio solution, right? For the summer vacation. Once I'm back at my house, that's where I'm gonna have all of my 3D printers, all of my robots, laser cutters, and so on available for me. Right now, I don't. And that's why we're doing the model by hand. You know, it is what it is. So expect an increase in videos, in amount of videos, and also the quality of videos will increase starting September, as per usual. Hi there, I was using a little bit of stick glue to fix printing onto balsa. And I was making balsa airplane models. Just wait a bit before starting. Yeah. The stick glue would work great instead of pens. I don't have any. I don't have any. I forgot to buy the stick glue, but that's fine. We have we see it. Not really. Kind of hard to see it, but I do think you can see it, right? I'm going to trace it that way. It's gonna cost me like what, extra half an hour? It's fine. Not a big deal. Analog Gediminus. Already the cutting pad doesn't heat up like that. Yeah, I'm much slower with the cutting mat, so it's not gonna heat up. Man, I miss the good old days of just working on the physical models. These days, you know, you just kind of model something out in Rhino, plot out your 2D parts, laser cut them out, and you're done, right? You're golden. But at the good old times, this was like at the end of the semester, this would be your, what, 2 weeks of just sitting there and hating your design, but at the same time kind of evaluating if the design is actually worthwhile, right? Evaluating if you did a good job at designing. This is so relaxing. Good. Unfortunately, it's not raining outside. This would be for... Wait, now it's midday, so for Japan and later for China, it would be like a sleeping pill stream. Come on. Come on. Ah, crap. Just a cut. Come on. You can do it, Brick. Ah, there we go. Perfect. Perfect. Knife slips, it will cost more. True. True. This is why all student models were very simple before all the machines. Not real. Yes and no. Like, I was studying in the Arts Academy in Vilnius, right? And we... Like, my generation was the generation where they actually introduced laser cutters to... And later CNC mills. For the students in the Arts Academy. But before that, like while I was in the first, second, and third year, we just did everything by hand, right? And there was this teacher called Bredikis. Those of you who are not Lithuanian will not know him, but he's kind of a he was kind of a big deal in Lithuania as an architect. Did quite a few interesting buildings. And he was like 90 or 85, something like that, years old. And he was teaching bionics to master students in the Vilnius Academy of Arts. And they did bionic architecture, moving architecture, like organic and crap like that by hand. Balloons and shit, you know, the whole 9 yards, how they say. They did everything by hand, and that was impressive, to say the least. But those, I guess, those were master students, right? Just weird to kind of think about it, that an 85-year-old guy, you know, would teach bionics while rest of the staff in the Arts Academy would barely understand what BIM is, you know, what BIM modeling is. That was a little bit of a strong contrast, to say the least. Was a strong contrast. We're gonna fix the crappy bits here. I think this is gonna work. Organic shapes we did was with condoms and gypsum. Perfect. That's excellent. I'm gonna grab some sandpaper in just a sec. This is gonna be a little bit of an aggressive one, but I think that's gonna work out. I'm just gonna remove the inconsistencies. Wait, where was I? Oh, right. The plans for the channel. What are the plans for the channel? So now the idea is that we are going to, as the new semester starts, we are going to continue working with the ABB robot in Lund University. And I'm going to be revisiting the code that I wrote for that robot, for the control of that robot in Grasshopper, right? We are going to still do hot. Well, it's not going to be hot wire cutting. It's going to be hot knife cutting. We're still going to be doing that, but it's going to be much more controlled, and you will not be describing the form via how the wire moves, but rather the wire movement will be following the form that you have described, right? So you first model something out, and then the Grasshopper code is going to evaluate it and rate like G code for the robot, how, instructions, how the robot needs to move. So that is the goal, the plan, right? I haven't started doing it, but I think we will need to use voxels for it. And of course, everything that I'm gonna be doing, I will be uploading it to YouTube, so that all of you can actually see it. That's fine. So that all of you can see it and maybe get inspired to do something similar. At your university or wherever you can get access to even a cheaper robot, because it doesn't really matter what kind of robot you use. What matters is the code that you feed into it, right? The expensive robots just can do things faster. But with wire cutting, or in this case hot knife cutting, speed is much more controlled by the density of the foam and the temperature of the knife, rather than the price of the robot. Like those of you who saw my previous videos with the ABB robot have seen how slow it moves, right? Is it G code in the end? It's called rapid code. It's not G code because G code uses XYZ coordinates, right? Like it's a linear Cartesian grid for the G code, while the rapid code uses angles of the 6 axes that the robot has, and also not just angles but also angles. It's actually pretty cool how they calculate it. They use these things that are called quaternions, I think. I don't know, some sort of a four-dimensional concept. So they use that four-dimensional concept to calculate where the robot arm needs to be, right? Which I find very interesting. And it's very hard to understand, to get into, but thankfully it just kind of Grasshopper just translates it into these kind of instructions, or not even Grasshopper, but Rapid Code is translated into Cortinian instructions, I think, inside of the robot, right? So we don't need to really work with it or think about it. Greetings from Stuttgart. Oh, Stuttgart, that's a nice city. Love your channel. The V-Ray series helped me a lot with university work. Well, that's the plan, right? That's the plan. That those videos are helpful not just to my students in Lund, but also, you know, to a student in Stuttgart, for instance. Those and the V-Ray series were super fun to record as well. I don't know, something about making visually pleasing things. I just enjoy that. Okay. Third pass, and we're gonna be done with the first part. Other parts will be faster, because this one is just, you know, it's a circle in a circle, so it's kind of slow. Oh, come on. Let's see if I can do it this way. I'm actually thinking of doing, like, while we're on the topic of 3D rendering, I'm actually thinking of doing a comparison video where I'm going to compare different 3D rendering engines that students tend to use. Lumion, V-Ray, maybe even Corona. Not sure about Corona. And then kind of give you my thoughts on them, and perhaps suggestions on what to focus on and so on. Go outside the magnifying glass. Well, I would need a pretty damn big model. You know, the diameter of the burn area would be a little bit too big for this kind of a model. Oh, Blender Guru already did this? Ah, oh, god damn it. The guy just beats me to every idea. I might do it as well. Did he do it for V-Ray in Rhino? Amazing content. Keep up the good work. Thanks. Thank you. Oh, he did it for V-Ray as well. Okay, fine. I'm not doing that then. Just watch Blender Guru's thoughts. He's pretty good at what he does. And then pretty knowledgeable? Is that the word? Yeah, V-Ray is the... I know that V-Ray is fastest. Except for, you know, Eevee in Blender. But that's unreasonable. Eevee is not ray tracing engine, a ray traced render. Not true to life. Slowly. This piece of crap is bending as well. Come on. Come on. I'm really trying not to break it. Okay. Okay. This part and go to hell. Now we have just a little bit more left. So many new 3D live rendering programs now. Oh yeah, and there's gonna be even more. Because we finally have hardware that can keep up with the real-time rendering, right? So finally we can get pretty damn close to photorealism with real-time rendering. And imagine, this is like the wet dream for an architect, right? That you can get your client to interact with your design in real time, right? As you're showcasing it. So of course it's gonna keep moving in that direction. You'll see. Eventually, I would say in like 5 years, maybe 10, we will not have non-real-time rendering. Everything is gonna be like in 5 years we will have Unreal Engine 6 probably, or at least an alpha version of Unreal Engine 6, and with that one there's no chance. Because you need to think about AI as well, and how AI is progressing. A lot of it is going to be filled in. I want to say interpolated or filled in by AI. Have you seen channel 5-minute papers? Yeah. I've seen all of them, all of those videos. Pretty good, but it's most of the papers are from not Skyarc, SIGGRAPH. That's and he doesn't cover some really interesting ones as well. I have no idea why. Maybe they have some sort of a non-disclosure agreement or something like that. It's mostly flowy water and cool fabrics that he's talking about. But yeah, those 5-minute papers are really cool. Okay. We have done one part in like 20 minutes. This is not good. But this was the hardest part to do. So my hopes are that it's gonna be faster. Okay. So technique number 1. That is kinda, it works, but it's shit, right? Let's try out technique number 2. Technique number 2 is going to be, rather than putting pins, we will trace over the model, not the model, but damn it, over the drawing. This is our part 2. Oh crap, this one is a circle as well. How many of these do you need? For this part, so there are 4 parts in total, right? Like this whole building is made out of 4 parts, and this is the smallest one, and the smallest one has 12 of these cross elements. The largest one has 67. So the answer is I will be cutting them out off stream And then the next stream that I'm gonna do is we will just magically use or not use, but see all of these already cut out, right? Isn't it more time efficient to cut it out with a laser? No shit, Sherlock. Of course it is. I don't have a laser. Well, okay, I do have a laser, but I would need to pay for it, and I don't wanna. And also, I wanna just see how fast can I do this by hand. How fast could I do this thing, you know, this model, physical model by hand. So it's gonna be... Wait, I need to cut this away. That's not in the way. So it's gonna be something like around 24 hours of cutting, I think, for the whole model, which is fine. I can kind of go through it because I have a few audiobooks that I need to, I don't know, do you call it reading? Listening? I need to listen through them. So it's fine, I can do it. It's just a little bit annoying that I need to. I am looking for a pen, and I don't think I have one. Let's see if this is gonna work. I have like a weird pen here. Can we make this a little bit less intense? This, focus, focus, focus. This better? This looks better, right? A bit better. And now with the pen. Nope. Nope. Not good enough. Not good enough. Technically, I could just try cutting right on top of this, right? What's the worst that can happen? Let's try. Famous last words, huh? Seems to be working fine. Starts curling. Yeah, shit. That. It's a knife just to make the groove. Yeah, I get what you mean, but this is one of those things that sounds good on paper. Apparently like 2 millimeters is not that... Ah crap, but I also need that. Imagine how architects used to cut what? Wooden models even bigger than that in the past with no audiobooks. Well, they got paid. They got paid. Okay, let's use the old trusted technique. Of marking it out. Actually, the marking part is not that bad. Like, it takes what? A minute? More? 2 minutes. To do one perimeter, so it's like 4 minutes to do the whole piece. If you have 60 pieces, that's gonna be 2 hours of marking. That's not, nah. The problem is the cutting, the cut speed. And I don't know how to increase the cut speed. How to make it better. Well, laser, duh. But besides laser. Goes faster for the each piece you do? Yeah, probably. The nice thing about airplanes is that their elements are kinda self-similar, right? So you can kinda cut out a larger section of them. Let's say for a wing, right? Ribs for a wing. You can cut out like all of them slightly bigger and then put them in clamps as a group and just shave all of them together in clamps. That would be nice, but I don't have clamps. I will need to get clamps though, because we will need to make a few incisions here. Huh. We'll need to figure out how to get clamps. Is that the Farnsworth house? No, that's my house. Sub D house. You can see it in the like previous 20 videos were about it. Me modeling it out on the channel. Looks like it should be thinner to cut easier. Maybe that is the answer. But this is already 2 millimeters. Like 1 millimeter balsa is not great to work with. Not great at all. Right? Crackmalus is cornstarch. And yes, I will probably make glue from that. Unless I will be lazy. Then we're just gonna use wood glue. Whatever. What are you going to use for walls, roof, and floors? I am going to use Chinese origami paper. Is it origami paper? I think it's origami. Chinese rice paper. Paired with this bad boy right here. I'm just trying to find a name of it. Anyway, this is like glycerin. Nitroglycerin. I think it's wait, no. It's not glycerin, but it's nitro glue. Super lightweight glue that can be used to cover rice paper to make it water resistant. Boom. Nitroglycerin. No. Just nitro. Bam, bam, bam. Oops, that's a miss. need to not miss these. So a few streams will be a little bit more chill like these. Again, next stream I am not, and next stream is not going to be super immediate on this one, because I will be cutting these out off stream, most of these out off stream. So, you know, it's gonna take me a little bit of time, because this is not the only thing that I do in life, right? But eventually we will get to it, and I will finish up this model. In the meanwhile, I'll probably need to help out with the very good architecture company and do a few renders, a few designs. Maybe I'll record one of the designs as I'm going to be making it. Again, a single family house. But I don't know. Somehow I really like doing single family houses as opposed to anything that's bigger, just because it feels much more personal, I guess. Like, you can make these small architectural decisions that not necessarily make no sense, but that only have an aesthetic logic, right? So the reason why they are in the project is just purely aesthetics. If you're doing anything else, any kind of other building, unless you're, you know, a star architect, you will not get that opportunity. Like in an office building, for instance, you will not get that opportunity to do so. So doing what's it called? Family houses, real nice, at least for me. All right. Video idea: making a real-life model for a tensile pavilion made with kangaroo. Maybe. I did that for my master's project, but I skipped the tensile part. Like, I didn't use a stocking or anything like that. Well, I used stocking material for my tests. And show you my... Wait. Let's do it like so. Just a second. I'm gonna show you my master's project with the tensile things. This one can become small. Oh, small. Right, like that. Just bear with me for a second. I don't have a mouse, so I need to do this real slow. There we go. So while I was testing out my, like the kangaroo model, while I was testing out the kangaroo model with the nylon stocking material and so on, the physical model, the final physical model that I did was actually 3D printed. just to fill in the nice aesthetic of it. And to tell you the truth, this whole model, this is not from kangaroo. Well, it is from kangaroo, but it's not from kangaroo simulation. This is from remeshing in Kangaroo 1. We're using Mesh Machine in Kangaroo 1, right? And saying that the final mesh should be smoothed out. So if you're smoothing out a mesh and you have a locked boundary, it's going to give you a minimal surface, right? Which incidentally is also a tensile surface, right? Because back in the day I didn't know how to use Kangaroo 1 and how to do those kind of things. So I kind of did that, and honestly there's not much that you can, like, you just take a piece of stocking and you just stretch it out, right? Not much else. I don't know. Unless we figure out something that would be worthwhile, then for sure I would be all up for it. And by worthwhile I mean something new, something unexpected. Maybe like, you know, Frey Otto's soap bubble experiments, the experiments that he did with the soap bubbles, something like that, right? Is it hard to make fluid air simulation on Grasshopper? Sample for fan cooler for 3D printer. Ooh. Yes. Kinda. Like, there is Rhino CFD plugin, right? And it makes it so that it's very easy. Very easy to make a flow simulation in Rhino with Rhino CFD plugin. The plugin costs more than Rhino itself. And the cheap alternatives or free alternatives to it are not ideal. Let's say it like that, right? So the answer is, if you have the money, yeah, it's easy, super easy. If you don't have the money, I would find a different program to do those kind of simulations with. Thanks for showing the project. Definitely going to check your website. That website is dead. I haven't updated that website in ages. The research that you will find on that website is 2 years, 3 years old, something like that. I have done much more, but honestly, you will figure out much more about the research that I'm doing from my YouTube channel rather than from that website. Just because if I figure something out in terms of aggregates or in terms of voxels, you know, voxelized architecture, if I figure something out, I will be uploading that to YouTube immediately. Except for a few small things that I'm still working on and that are too tricky to explain in a single video. Those I haven't uploaded yet, but I will once I run out of video ideas. For now, the one of the more interesting ones that, at least in terms of design, that I'm really looking forward to uploading is an update of the custom marching cubes algorithm. Because the custom marching cubes algorithm that I have done, you know, the 5 or 6 part series that I have done, kinda runs out of memory if you reach, a few thousand elements. And I have updated it, and now you can get away with more than 1,000,000 elements. With 16 gigabytes of RAM, by the way. If you have 32 gigabytes, that's gonna be much, much more. At that point, you will be running out of video memory rather than computer memory, or just simply displaying all of those elements. So that's going to be a pretty cool update, I think, to the and kind of like the final update to the definition, which will make us create or grow cities with a single click. Enclosed working city. Then we will be able to grow those cities according to certain rules, such as amount of light, that each of the clusters needs to get, or amount of noise that each of the clusters should not exceed, and so on. That is going to be, I think, a pretty big deal. Because, like, simulating a million pieces is pretty intense. I'm pretty happy that I managed to optimize it so that it actually works. You kind of saw my tests in the how to speed up your Rhino file video. Those were my initial tests, and those only had a few thousand elements. And I stress tested it, and it reached 1,000,000, more than 1,000,000, before the screen just froze. And I think it froze because of my graphics card. That's fun. That's fun. Also, I might do a live stream, not a live stream, sorry, but I might do a travel vlog, like a good YouTuber that I am. Because I have plans of going to the Venice Architecture Biennale this year. And I might record a few days there, just walking around, looking at the cool exhibitions and so on, and kind of documenting those exhibitions, what I find cool, and uploading some sort of a short video to YouTube. But that's gonna be in September, late September. Can you use mesh lights as blocks? I believe you can. Alternatively, you can kind of use emissive material, that might work. Have you tried Dynamo or just Grasshopper? I have tried Dynamo. I have tried Dynamo on a few occasions. And on every single occasion, I would throw it as far as I possibly can. I don't like Dynamo. It's not great. I think it's because of the structure on how Revit works, right? That's because of the structure. Dynamo is just how do I say this? It's slow and it's clunky, right? And I actually talked with the creator of Dynamo. I have an anecdote for that. For those of you who haven't heard me saying that, I will tell you a story. So I'm a teacher in Lund, right? So I need to take these pedagogical courses to increase my qualification, blah, 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 to become a senior lecturer, right? Rather than just a lecturer, right? So there are these kind of a lecturer, senior lecturer, kind of professor associate, and then professor, right? These steps. And to go from lecturer to senior lecturer, you need to have X hours of pedagogical training, right? So that's the short backstory. And I was taking these courses, and those courses are being taken by not just the architecture school teachers, but also by all teachers in Lund University and affiliates as well. So there were quite a few students from physics department, teachers from physics department and so on. And there was one guy from the UK, right? Was it Cambridge? I don't remember the university, but he was from UK, and he was in my group, and we kind of chatted, and I said that I'm an architect, and he was like, "Oh, cool, do you use Dynamo?" And he introduced himself as a computer science teacher guy, startup manager as well. And I was like, "Yeah, I used Dynamo, but that was complete garbage, complete shit, and so on." Yep, and then one of my group mates just writes me in private chat, "Yo, that's the creator of Dynamo that you're talking with." That was fun. We talked it out. I'm trying to get him to do a podcast on the YouTube channel. But he's not replying to my emails anymore. Wonder why. Make tutorial for drawing preparation for printing. Like line weights and shit like that? Maybe. But that would be with this. That would be. What would I tell in that tutorial? Just make the drawing nice and press Ctrl P? I'm just wondering how that would work. Jesus Christ, cutting this out is a pain in the ass. I'm so scared of breaking it. Like, I'm doing this in like 7 different passes just because I'm scared of breaking the thin part of the balsa wood. Not great, not great. But we're almost there. There we go. Finally. Jesus Christ. Okay. And now to finish off the ring. Once I'll finish this element right here, I'm gonna show you one little trick. Where was I? Sorry. Oh yeah, I'm gonna show you one little trick how I create. How do you call them? Like tools for creating really thin strips of balsa wood. And that's after I finish up this little element right here. Hello man, love your tutorial, many thanks. Happy to hear that. Honestly, always happy to hear that. Scales, layouts, managing all those crappy pages. Yep. That is the crappy bit of Rhino, huh? Like needing to actually make the layouts work for you and not against you. There's a whole forum, like not post, but forum thread on McNeil forums about Rhino 8. By the way, did you know that you can actually, if you have bought Rhino 7, you can get Rhino 8 already, like a beta version of it, or alpha, no, VIP, work in progress version of it. And you can test it out and see, you know, if the improvements that they are making are nice or not. So the Rhino 8 version, they will be revisiting the plotting styles, the line weights, and so on, which I'm really happy about. And I really hope they will do that, because goddamn, those are the worst part about Rhino by far. The layouts. I have talked about, by the way, Thomas. I have searched for course AADA10 on my channel, and the last video of that course, part 3 of AADA10 course, that is where I actually talk about the layouts and how you can kind of work with them through and through. Maybe that's the video that you're looking for, or a video that you're suggesting rather. Yeah. Thanks for sharing your knowledge. Well, I don't know much, but I do share much as I can. Yeah. Come on. Stupid balsa rings. Maybe I should just laser cut it and lie to all of you saying that I did this by hand, but you will see the burned pieces, right? I will not manage to actually persuade you that I cut all of them by hand. I need to find a way of how to cheat. Or maybe I just give up and laser cut it and just tell everyone that I gave up. That's also a way. How do you keep up the creative spirit in these COVID times? The COVID times are the times when the spirit is the most creative, because you're bored out of your mind, right? So you come up with different ideas and things that you want to do to keep your mind away from the fact that you can't travel where you want to travel, you can't meet your parents, and well, now you can, but you know, back in the day I was living in Sweden, couldn't meet my parents, and so on. So you start drawing or modeling or both, you know, just doing stuff that will take the thoughts away. Or just watch cool shit. Watch cool stuff on the internet. Right? That's also a way to go about it. You can, for instance, has anyone seen Bo Burnham's Inside? That's a very good piece of art, honestly. That might inspire you to do more, because that's something that he did by himself, right? Which is super impressive. Maybe if you haven't done YouTube videos, then it doesn't seem as impressive to you, but trust me, like pulling off that kind of production quality, goddamn, that's some freaky crap right there. Do hatch suck only for me? No, not only for you, for everyone. Is there a way to get hatch for slice automatically? Is there? Crap. I think a human plugin has that, doesn't it? So in Grasshopper, yeah, kinda. But in Rhino, automatic hatching, no. But in Rhino, you can get clipping plane intersections to be exported into a separate layer, and then just hatch inside of that layer. It's not automatic, but at least it gives you the nice outlines, as long as your 3D model is clean. That's one way. Bro, what you doing? I am making a ring, a balsa ring. Actually 2. Where's my other one? 2 balsa rings, right? I'm doing those. I'm gonna be making a 3rd one now. But before we do that, I will create a tool for myself. Turn this on. Okay, so we need like 1mm piece of balsa wood. Oh, that's a thin boy right there. Oh, it's a thin boy. And this piece of balsa wood will need to be cut. Actually, it doesn't need to be that precise, but I kind of want it to be precise, so I'm gonna use another piece of balsa wood as my ruler. Okay, so let's do 4 by 5, I guess. No, let's do 3 by 5. Something like that. Just bear with me for a second. I'm gonna show you what's up in just a tiny bit. For now, we're making some cuts. And as I have many numbers in my head, I can't really also explain why we're doing what we're doing. Just that one. Yeah. That will need to go here. We'll need to be marked out. That one, like that. Here it can be just a freehand cut. That's fine. If you're smoothing out the edges anyway, I guess you can get away with laser cutting the balsa. Oh yeah, that's not the problem. That's not the problem. The problem is that I am a very stupid man. That is the problem. And you know what stupid men do? They overestimate their capabilities. And I did it. I overestimated my capabilities. And since I did that, since I did that, I said that I'm not gonna use a laser. But this is just an ego thing, is why I am not using a laser cutter. I think I will, and I'll give in and just say I was wrong. But for now, you know, the stream is running, so might as well keep going with the stream. Once the stream is done, I might order some laser cutting services. We'll see. We will see. Ooh. Is there a way to export PDFs from Rhino that are correct for plotting? When I import Rhino PDF to Illustrator, it's not 100% correct. It should be. It should be. Depends on what kind of plotter you use, though. But it really should be. That, and now I'm gonna... You still have no idea probably what I'm doing. So yet again, I will say, trust me. Trust me. We are making ourselves a tool. A very, very simple tool. But that very, very simple tool is going to save us a lot of time. Okay. I need to remember now. So this needs to do this, right? Something like that. So the idea is, imagine you have a piece of wood, right? And you need to cut away a 1 millimeter slice from it. The thickness of this cut needs to be 1 millimeter. So what you could do is you could take a ruler, you know, kind of mark out where you think 1 millimeter is, and you just make a cut. And you just pray that the ruler doesn't move and so on, right? And you end up with you know, with a cut. A little bit of a cut. That's fine. But you can also make a sandwich knife. And for a sandwich knife, you need 1 millimeter thick piece of balsa wood and 2 other balsa wood pieces that are not 1 millimeter thick, I guess. You know. And basically, the idea is that you take a knife, you take one piece of wood. Let's do the bigger one. you take a knife, you place a knife, no, sorry, you take your 1mm piece of balsa wood, you place it on top, like that. So now there is a gap here that is 1mm, right? Then you take a knife and you put it like so, right? Something like that. So now there is a gap of 1mm between the blade and the thing. God damn it. And the back plate of the balsa wood piece, right? So you do that, and then you take there, and then you just take another piece of wood and glue it like that. So you are left with, let me try and take all of this together and show it to you closer. Zoom in. So you're left with something like this, a knife that is 1mm away from the back plate, which means that if you then take the, this contraption and you cut with it, the slice that this knife makes is going to always be 1mm, right? This is a very nice little tool to actually have and to actually kind of use. Now I can see that my back plate is a little bit too big. I think that's like one full centimeter. I'm gonna cut a little bit away from it. Maybe something like that. You don't want the knife to protrude too much. If it protrudes too much, then it's going to be a shit show, right? It's not gonna be accurate at all. So 1 centimeter is too much. I would say somewhere between 5 and 6 millimeters is best. I'm just gonna cut away the excess, the unnecessary bit. Okay, what's up with the chat? If you're smoothing out the edges anyway, I guess you can get the... Oh yeah, I already talked about that. I'm an architect, and in this time of code, I'm interested in augmented reality for architecture. What do you think about this idea? I think it's a great idea. Augmented versus virtual reality though? Not sure which one is better. Maybe augmented is better, but the technology is kind of crappy for augmented reality. You know? So I would kind of investigate virtual reality a bit more, and then once the technology for augmented reality catches up, then I would transfer my knowledge that way. Radiuses get messed up. Oh really? So you're talking about plotting from Rhino into Illustrator, and then radiuses get messed up. I never seen that. Never seen that happen. So I don't know. Looking forward to see what turns out of this. Yeah, same. I have no idea what's gonna happen. Hopefully something cool, but no promises. Chat is talking with chat as well. Check out the new building created in the University of Sydney. It's made by Frank Gehry, and they used augmented reality to lay the bricks. So oh yeah, that one. That's actually a pretty cool one. Pretty cool way of how you can use augmented reality. Just for presentation purposes, doesn't make sense. For manufacturing purposes, though, makes a lot of sense. I need glue. Wait. Okay. Glue glue. We're gonna use glue. Did you mark parts which side is which? Maybe. Right now, since there's not a lot of parts, I don't. But once there's a lot, I will be marking them out for sure. Moment of truth, I guess. Let's glue this whole bad boy together. You. Oh yeah, I forgot that Balza grips like a crazy person. Damn, that's a strong grip immediately. Like that, and then here we actually need a lot of glue. Because this blade will really need to be locked in place for this whole thing to work. That. Great. Okay. Last bit is here. Okay. So we have this contraption here. Add pins through wood. Maybe. That's a good idea. But if I add pins, then I can't put any weights on this. I want to put weights on this. Oh, so that the blade has support. Sure, that's a good idea. But maybe later, maybe after. Yeah, I'm gonna do that, but I'm gonna do that once this whole damn thing dries. Because we need to. There we go. Because I need to add weights to this first. Great. Should be fine. Speaking of weights, be right back. Need to find like 50 books that I can use. Okay, should be good. Should be good. What do we do now? What do we do now? Now we have a crap ton of sunlight just blasting at my back. And we have quite a few elements that are left to be cut, but we managed to do electronics quite well. Honestly, and the electronics worked. Maybe I wanna work with electronics a bit more. Because this, I will be laser cutting, I think. Maybe. Wait, I'm thinking. Like parts of it. I will be laser cutting parts of it, not the whole damn thing. Let's do electronics. Let's do electronics instead. That's gonna be more fun to see. The music intensifies. Won't this wood bend and warp when laser cut? Not that much. It will, for sure it will, but not that much. Also, we can unwarp it quite easily by just simply putting it in water and letting it dry out under pressure. That's not an issue. Gonna be fast. Okay. Let me clean up. I have like a crap ton of junk around. This goes away. Calipers. Little blade here. Oh, but wait, we will need to. Yeah. We'll need to see how this, how the motor spins. So I guess. I need to add something to the motors, right? Be right back with some electronics. Ta-da! Those of you who were not at the start of this stream are probably thinking, what the what the hell is going on? Don't forget that this model, the balsa wood model that I'm making, is going to be controlled via Arduino. And it's not just going to be controlled, but it's actually going to move, right? That movement is going to be done by this little thing right here, which I'm actually going to, oh my god, the light. Oh, light. My whole back is completely wet from the sweat. Yeah. So we're going to do a little bit of a flag right here so that you can see. If I now take this and plug it in, there is only a 50-50% chance that it's gonna burn. It's not burning. See that? Yeah. Yeah. That's all it does. that's all it does. It just spins. And also it spins kind of shitty. But now we also have the rotary encoder, which is this knob right here that I can turn, right? So we're going to work with it for a little bit. And to be able to work with it, I need my keyboard back. Keyboard back. That's not a keyboard, that's a keyboard. There we go. Moving things around. Moving things around. A second. Is it a stepper motor? It is a stepper motor, yes. That is being fed directly from an Arduino Nano. I have no idea why it's not burning, but it's not burning, so we are sticking with it. Again, please, anyone who has like at least a few neurons, don't do this. Never do something like this. This is electricity hazard, right? This is a very bad idea to do it this way. But hey, I have a YouTube channel, so I can. Okay, so we have that, and now I need to make this like that. Actually, we can probably have it bigger, right? Yeah, something like that. And I'm like that. Okay. Arduino. So the idea is we have two encoders, so not two encoders, but we have two codes. We have this one right here, which basically controls the spinning. And I will also open a recent file that is this one, which basically works with the encoder, the knob. Let's call it the knob, right? So it works with the knob. Right now, these two codes are separate. I need to make them kiss somehow, right? So the first thing is, which one do we connect to where? I think we will bring in the stepper motor code into the knob code. So before we define anything, we include, then we do constant integer. That's number of steps, right? Yeah, I think so. We can do it like that, and then void setup is right here. Oh wait, no. Before that, a new stepper motor is created, right? And then we do a setup. Do you see it? Yeah, you can see it. And then here there's like a crap ton of, in the setup there is the pin A and pin B. I have no idea what this one is though. Why Control Z doesn't work with deleted saved views? Oh, yeah, that doesn't work. That kind of boo boo. Unless there is a way of how you can go back to the previous view in Rhino. Under Rhino, this one needs to go away. Under set view, you can jump back to or undo view change. This icon right here. But if you weren't in that view, then time to replace the camera, unfortunately. Okay, so back here, oops, not here, here, and here. Stepper. Okay, so we need to set the speed. So the speed of this rotor, this motor, is being set up here under void setup. Then serial, that's whatever. And then my stepper steps per evolution. Okay, good. So this is the one that is going to actually, yeah, this is the one that's actually going to work. Oh my god. Sorry that I'm blabbing. It's just I'm really thinking. And also I can't see my mouse here. I had like 12 views here. Well, rough day, huh? So, okay. Steps per revolution. Let's say if rotary value is larger than last rotary value, print clockwise, right? And then do encoder. If digital read, if this is not this, then position has changed. But if this is, sorry, if this is this, oh my god. Okay. I'm gonna figure it out. Trust me, I'm gonna figure it out. We just need to. Okay, so definitely not that, not in the setup. Under loop, that's gonna be under loop for sure. If this changes, then this should step. Right? Right. Steps per revolution. And can I do, so if it's 2048, if it's 2k steps for 360 degrees of movement, then one tick here needs to be like 10 steps. No, not 10. 10 is not divided by 10. Okay, where's my notepad? Yeah, trusted notepad. So 2840 steps is 360 degrees, right? So around 200 steps is 30, around 36. No, we should be dividing it by half. 4 steps equals 180. 512 equals 90. 256 equals 45. 128 equals 22.5. 64 equals 12.25. Okay, so around 12.25 points. I think that's not points, degrees. I think that's reasonable. So we need to do 64 steps with a 2K stepper motor, right? So here under step, I can just write 64, right? Yeah. Oh wait, 11. Yeah, thanks. 11.25. Quick math. So then it's gonna step 64 steps, and if it's counterclockwise, it's gonna step negative 64 steps, right? And then the whole encoder void, which I have no idea. Do encoder. Do we have? Where do we have this do encoder else? Oh, here. Attach interrupt. I have no idea what that one does. Do we care? We don't care, right? We just press play. Upload. Okay, it's compiling. It is compiling. Technically, this should stop moving. It just did. Okay. Now we should, if we open up serial monitor, it's just giving us a big strong 0. That's because we haven't rotated the little knob right here. Do you see the knob? Wait. I need to find. Yeah, you see the knob, right? You see the knob and you see this little doohickey here. And now technically, if I rotate the knob, click once, shit, nothing changes. Okay, click. Okay, now it changed. And this is moving. In the shittiest possible, what the hell? It keeps going. Oh. So now you know what we're doing with this code? We're describing the speed, right? Because now if I increase it, yeah. Now if I decrease it, it still goes in positive. Okay. That's weird. That is weird. What if we do 0? It doesn't move with 0. But with -1, it moves clockwise. And with positive, guess what? It moves clockwise. Okay. back to 0. We investigate further. This one is fine. That's whatever. 64, and that's negative 64. So it should technically work. What if oh, I know. Wait. 64 multiplied by btn. Because btn is this number right here. You know, right now it's 0. But when it's 1, it needs to be 64 multiplied by 1. When it's 2, it needs to be 64 multiplied by 2, right? And this is negative 61 multiplied by btn. This should work, technically. And now, oh yeah, btn goes to minus as well. That's correct. But let's see if it's gonna. Now this is spinning, and it should stop, but it keeps going. It keeps going. No. So yeah, that's the 64 and 64. That makes sense. Rotary value. Last rotary value. Where does the last rotary value come in? So if value rotary, if rotary value is larger than last rotary value. But wait. So is btn I'm trying to set position. So I don't think btn is I think the rotary value is the thing that we want to use, right? Or is it not? I'm confused now. I'm not adding, I'm multiplying. But I think we can kind of try doing that. No? Okay. Because I think the rotary value is not. Now it still does that. It keeps adding. Yeah. It keeps adding it. I will need to figure this out later. Or I'll need to figure this out later. Now this is way too confusing. Because BTN add then multiply. Can we get the command box in Rhino in the bottom? Yeah, you just take the command box and you just drag it to the bottom. And then you have it in the bottom. Drag and drop, drag and drop. I guess I need to read more about this because I wasn't correct. The BTN that's this, right? That's the one, and rotary value is this. If I just get rid of BTN altogether and upload, this is still gonna, or printing of BTN, this is still gonna work. It's just not going to give me, yeah, it's just not giving the number one, right? So now it's 0. And now if I move it, now it's 1, 2, 2, 2, 5, 8. And it's becoming slower. Super strange. Super strange. Okay, go back to 0. Okay. If, oh, I know. Okay. Easy hack. Just simply last, or rather, rotary value minus last rotary value multiplied by 64. If these are the same, if I didn't turn the knob, these will be the same. And that means the knob will not, sorry, not the knob, but the motor. The motor will not turn because this is going to be 0, right? Like previous number and the current number will be both the same. So this equals 0. 64 times 0 is 0. And then the stepper will step by 0 steps, meaning it will not move. But if I rotate it, this is gonna add up. So this tells me that I don't need an if statement here. And then I don't need an if statement here. All I need is just this little line right here. Error operating serial port COM3. Oh no. Oh no. Did we break it? Did we break it already? We might have. It's not burning. Oh, never mind, it works. Okay, so now it's 0, and this bad boy is not moving, right? And then if I turn, please work, turn. Hell yeah. And now I turn it backwards. It still turns forward. Fuck. Why? Why do you turn forward? At least it works. At least now it's kind of, it stops turning when I stop turning this, right? Okay, so that part works. Close that. Can we make this faster? Speed is 5 steps per second, probably. Let's do 10. Let's double that. That shouldn't be by second. Anyway. Then we do wall rotary is indeed knob's position, yes. Actually, I kind of want to see this one instead. Not just this one, but also this one. Let's just multiply it as well. Let's just see exactly what kind of steps this the stepper motor is getting. Let me upload that. Okay. Serial monitor. Okay, so now it's clear. 0, 0, right? No movement. And then as I move the knob, as I rotate the knob, the second number should increase just in one position, while the first number will kind of just stay increased. Yeah, okay, so that was 64, yeah. Those are 64 steps. Huh? But you can see here that negative 64, it still turns in the same. Oh, wait. Huh. It's freaking out. Minus 36. Hmm. Okay. Okay. So it doesn't step backwards. Well, that's not good. How does the previous one look like? Examples, not examples, open recent. I'm just gonna test out this one of extra speed. Come on. Yeah, and are you gonna go backwards? No, you're not. You just keep going forward. Do you have spares of all parts? Yes, I do. I do have spares. So it doesn't go backwards. That's not good. That is not good at all. Okay, where's my trusted Google? Stepper motor not going backwards. Uh, Had to switch intake to. We're reading, boys. We're reading. It should. It should reverse current. At least that's how I imagine it's gonna. I imagine it works. Let's see what kind of steppers. So exactly the same steppers as I am, and driver boards. Okay. Int 2 and int 3 need to be switched. Ah, what the heck? We can't do that. That's fine. Eh. What's the worst that can happen, right? So int 2 and int 3 are now switched. Move. Move back. Shit. It works. Woo. Forward. Do you even see it? Forward. 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 And now backwards, backward, backward. Perfect. Okay. So that works. Now let's see. So the speed of it is pretty janky. And I think we're gonna leave it like that. for now. We can now do some sort of a quick little test, I guess. I'm so happy this works. Pretty bad. Pretty bad. Eh? Wah, wah. Oh. Oh, oh, oh. Okay. We have ourselves a little like the a start of a robot. Start of a balsa wood robot. I think I'm gonna call it a day here. What do you guys think? What do you guys think? I think this is a success. Except for the laser cutting part. That is not a success. I will need to laser cut it. Didn't want to do that, but we'll need to. Razam says hi. Hello. Welcome to the end of the stream. You just made right in time for the stream to end. I'm gonna grab some foodies, something to eat. So the next stream is going to be, maybe I can let's not do too much in one stream. Next stream, I'm going to have all of the pieces ready, all of the balsa pieces ready, because right now I only have like 2 of them. not great. And I will probably continue working on this as well as like actually assembling the physical model. I didn't talk about the size of the model, I guess. So the size of the model is going to be half a meter. So 50 centimeters. That's not the base, that's the building. The base is going to be a little bit bigger. So kinda excited about that. Should be pretty cool. Besides it, I don't know. What about cross sections? Yeah, they do need to. The cross sections will need to lock with current parts. I will be making small incisions here. That's not a problem because that's only going to be like a 1 millimeter incision, and you don't need to be. The positioning of it needs to be precise, but the size of it doesn't need to be precise because who cares? Glue is going to fill in the imperfections. So that's gonna be what we'll be doing next. I guess in a week or a few weeks or so, something like that. At that point, it's going to become a little bit more pretty, right? Because here it's just a random setup that I have. Not random, but a pre-setup, I guess, of of an upcoming build. My wood is different thickness. I have, yeah, it is. That's fine. Why would that be a problem? Oh, you mean, yeah, that's not gonna be a problem, right? So let's say 1 millimeter incision, right? Or I'm planning that my pieces are going to be 1 millimeter in thickness, even if it's zero in between 0.8 and 1.2 or 1.4 millimeters, that's fine because I am going to be cutting away. Like the incisions that I'm going to be making are going to be 1.4 millimeters rather than just, right on the spot, 1 millimeter ones. So that's not going to be that big of a problem. And also I can always sand down the model later. Yeah, I think just manual, you know, um, not assembly, but inter intervening manually, into the production phase. I think that's gonna work out just fine. Do I make cut on both parts? No, no, I don't. I only make a cut on the thick boys here. The thin boys are just going to be these thin 1 millimeter strips of wood, of balsa wood. I'm looking for a drawing. Not sure if, yeah, you can't see it at all. Wait, I'm gonna try and focus up on it. See how that wait, where are we? See how those lines are, oh come on light. Those are just thin those are just thin pieces of wood that are going in another direction, and they don't have a variance in thickness. Aligning will be done by eye, not completely, because I have these come on, what's up? Not sure if you can see anything there, but you can see all, yeah, you can see the slots there. So the slots are aligned, and all I need to do is just transfer those slots onto my balsa pieces and cut them out, and that's gonna be fine. That's gonna work. So that's what I mean. The incisions, those slots. Um, I only care about the position of them. The thickness of them, it can be a little bit washing. That's fine. Oh, how one circle is how far away one part is from the other. I have did I put it? I have drawings like these. Zoom out, zoom out. Yeah, you can kind of see it. You can't. So I have these plan drawings, right? I'm going to just take these plan drawings and I'm going to use the old trusted technique of uh, pinning the balls of pieces to uh, these plan drawings, right? One after the other, like that. And then once these are pinned, I'll start from the top and I'll I'll start connecting them with the cross bracing, cross beams, I guess. So I do have like a template on the positioning of these elements. So that's gonna work out, hopefully. For now, I'm gonna go and eat. I guess, yeah. Thank you. Thank you all for watching. I will do my best to have everything ready as soon as possible. But if you don't see a live stream um, in the next week or so, don't be worried. I'm not dead. Yeah, I'm off, guys. I'm off. Take care. Bye. 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 Bye.